All right. Live with SMART community, Smart AI community. Thank you all for being here. I am going to start sharing my screen. But as you all can tell, that today we probably will talk a little bit about some technical issues with AI machine learning and MLOps or machine learning, which is the MLOps. Um, we tend to take, mm, some turn in technical, non-technical management, something along the line of how the change management will work out. But to get into the technical means we have to keep it on a very surface level. Because the SMART community wants to advocate for everybody. So we really are striving to have everybody understand the technical details from a very surface level without losing focus in what it is that we have to do in order to adapt and implement AI without learning everything technical, right? Keep it surface level. And one of the ways I think we can definitely benefit from this technical knowledge is from MLOps technical knowledge. MLOps is a process that is very useful, not necessarily very useful. I think it is the only one that helps with artificial intelligence development and machine learning deployment, right? So wherever it is that we start with AI, it starts with MLOps, in my opinion, and that MLOps is very effective in its deployment capability, because if you can capture MLOps very well as a process, what you deploy is far more likely to be actually deployed and used and implemented for a lengthy period of time. One of the things that we have observed is that majority of the machine learning on AI use cases, they do not deploy and come to surface for the users to use or people to benefit from. There's a lot of ideas about artificial intelligence and machine learning, and the spectrum is very wide. But just because the spectrum is very wide, it doesn't necessarily mean that all the use cases are something that is deployable and usable and is realistic, right? And what I mean by realistic is it scalable? Is it sustainable, right? So when you think about machine learning, that's not what everybody knows AI for, but behind the AI that we are experiencing, machine learning is the key utilization tool, right? And MLOps is a way to develop machine learning, similar to how software and IT solutions are developed through DevOps. So if you're familiar with DevOps, MLOps is pretty much just another version of DevOps for the purposes of machine learning analytics and deployment of AI. So you see another piece of data engineering there. That's the original starting point of machine learning, where you have to gather lots of data sets and understand these data sets very, I would say, eloquently, because you have to understand some of those data sets. If they have millions of rows in them, not all of these data are relevant, and some of this data can confuse machine learning to a point that machine learning is no longer sustainable or scalable. So you really have to worry about your data sets, and data engineering is the phase where you inspect those data and make sure those data are relevant to what it is that you're trying to deploy actually. So, like, we are confronting with ourselves how to keep it as little technical as possible. Smart SMART community, we understand that AI is a new concept to many people, but some people, they have heard of AI for a very long time. And on this webinar, what we would like to do is articulate machine learning and talk about MLOps without really getting deep into it. But if you were to open the hood and look under what's artificial intelligence, it's mainly is statistics, right? And when you look at statistics, it doesn't really draw the crowd, as you can tell from the meme on the bottom, right? But you frame the statistics very nicely, and still doesn't draw any crowd. And you call it a machine learning instead of calling them statistics. People still say like, "Well, what is machine learning?" But as soon as you call it AI, everybody pays attention, right? So AI, statistics, and machine learning, depending on the degree of engagement or depending on the degree of your need, you probably wouldn't call it machine learning. You probably would call it AI. You probably wouldn't call it statistics. You probably would call it machine learning. And machine learning has its um, path forward. It has been around for a very long time. It is actually used in all of your device that you can call a smart device. They're all based on machine learning. Majority of them are. So if you want to go down the list of what's involved in machine learning and what sort of product that you use on a daily basis that has machine learning, you can Google it and you'll find plenty of them. And Google search being one of the top machine learning users. So as we move through this MLOps lifecycle, I want to go back to the data engineering piece of it. So when you have a organizational inspiration to adopt an AI or have an AI become part of your organizational daily workflow or organizational process, if you have a procurement process, if you have an auditing process, if you have a process of acquisition, or if you have a process of let's say deliverables, right? Where does machine learning fit in? Is it in the total ecosystem, or is it in pieces of ecosystem, or is it kind of temporarily just auditing what's being delivered or auditing the invoices that's leaving your organization, right? Payable and pay receivable. So as you're thinking about AI machine learning, there's cycles that you have to go through, but these cycles are always infinite, right? It doesn't necessarily say you start here, you end here. No, once you end, you start all over again. And if you look up some of the traditional AI systems, that's what it comes down to. You have uh, databases and you have application is what people uses mainly without understanding what database is. But these application has to create a feedback loop, the infinite feedback loop of having this data being processed inside of the database. So as you go through the data engineering piece of it and invest in your organizational need for data engineers, or upskilling somebody within your organization for data engineering, you really are thinking about data prepping. And once you have those data prepping, uh, that means you're having a data acquisition pipeline, and you're having those data being modeled and trained. And once they're trained, you have to audit them. Like test and validate them, sort of like audit, and then get them ready for deployment. And then you start that feedback loop all over again, because once it's deployed, it will start collecting lots of this feedback. So um, when we think of anything that we are recently learning, right? So going back to what we talked about earlier with DevOps and MLOps, it's always that everything we know is not really 100%. It's just that we know majority of this information. So same with DevOps, same with data engineering, and same with any subject matter expertise that we have or domain knowledge expertise that we have. So what we would like to do is give out a visualization, so that way you can understand that what you know actually is far more important than what it is that you don't know with MLOps or machine learning or AI. It's really important that you bring your specialty, your subject matter expertise to AI, rather than bring AI to your subject matter expertise. And what I mean by that is that if you have, say, technical understanding of how a architecture of a building works, right? You're an architect, you're an engineer, or if you are a, say, for example, a construction worker, right? How does a construction worker understand how construction works, and how does AI bring value to that construction industry, right? So really have lots of the subject matter expertise that we have to really bring ourselves to AI rather than bring the AI to us, right? So this is kind of the ways to visualize, how much do we need to know, right? What's 100% look like? And then how do we make it 100%? Even though there are some gaps there, but in knowledge, how do we combine these AI knowledge with your subject matter expertise is what's necessary going forward, right? Because there's a lot of AI models out there, there's a lot of data models out there. AI is not that difficult to actually develop. It's just a matter of how do we bring those two sets of knowledge together and combine it for a purpose of deploying a machine learning or having an AI that becomes productionalized. Like I said, I do not intend to make this technical, but I want to hit on the points that when you want to have a successful MLOps development, you really have to bring two subject matter expertise together. Either somebody who is a subject matter expert of your business process or subject matter expert of somebody of data of your business process. And when you bring them together, you start articulating the fact that machine learning and AI is the next evolutionary step from what it is that you've already accomplished within your enterprise or your organization, right? So one of the visualizations that I've shown you right now is that you're bringing in two data sets together or two subject matter expertise together, right? And in the simplest form, what machine learning is working with the smallest subset of data, which is that it could be a single record that needs to be taught to a machine through a model training. And once you do that over and over, it captures the bigger picture and it understands more and more of what it is that you're training those data for, right? So when I said, you have to have data acquisition and then that data has to be trained, what that means is that the smallest number of data is what will start the training, and then it will become an AI-like system that can actually train the model itself, so on and so forth, right? It can grow those data over time. So the smallest subset of data, like even a single record of data or single zeros and ones, means the game changer for everything that's AI. So when you see a lot of the Chat GPT that hallucinates or Chat GPT that doesn't give you the right answers, it's because there's some missing link all the way on the bottom of the database, and that's why the Chat GPT is not really responding the way you want it to. So in our world, the world that we have around us, if you think about it, this is a terminology that we use for semiconductor chips industry, which is of pick up and drop off, right? Pick up and drop off in a real world is you call an Uber, Uber comes and picks you up and drops you off where you need to go. But if you think about it, actually everything around us works the same manner, right? It's about picking up and dropping off, right? The information has to be picked up from somewhere and dropped off somewhere and used again and picked up and dropped off somewhere else. So there's a data in motion or intelligence in motion, information in motion, right? Whatever the case is, there's always in motion and always in use. So if you think about pick up and drop off and you think about pick up and drop off in a system, that's what's happening with information technology, with data, right? Data is being picked up from here, utilized here. So in MLOps specifically, it's being used here, but trained here for purposes of moving somewhere else and being used somewhere else. So data has gravity, data is in motion, just like we as humans are in motion, right? So data has gravity and that data moves. So whatever data you do acquisition for, and then however that data is being trained and modeled is a sequence of pickup and drop off. And it happens all the time right in front of you in your eyes instantaneously through complex systems like these or complex chart like these, right? But it's not, we're not going to go down that rabbit hole of HTTPS, TLS, and all this jazz. What that means is that as an end user, you are producing data or you're using data. Whatever the case is, it's all happening simultaneously. And you are connected to a database through all these devices that you see in front of you. But that means this is an actually that a visualization of a complex data transfer motion that's being presented in front of you in a simple diagram. So let me pause here and see, Evangelos, what is your thoughts so far? Like, as a person who's in the social science side of things, what's your thoughts on these MLOps?
I think that I keep some of the keywords you use. The first one was realistic, and then I tried to follow the reasoning in organizations. And I think one of my initial thoughts was, how do you achieve this type, the type of bridging you're delineating between? You also mentioned the term the subject matter, like merging to subject matter expertise, something like
That's
that.
right. That's right. Yeah.
Yeah. Um, and I was thinking, especially in the context of workplace and business and organizations, that the process, um, that the technical conversation is sometimes, I wouldn't say limited, but we circumvent to acknowledge that the whole workplace is being reconfigured by the inclusion and adoptions of these kind of technologies, not only in the spatial sense, but also in terms of human-machine interaction. So, yeah, it's, it's, I'm very interested to learn more about it.
Yeah, yeah. This is actually one of the things that I've always gathered feedback on, because I always ask this question to say, like, how does this make you feel, right? Because this could be overwhelming to somebody who doesn't really do data and technology or artificial intelligence, machine learning every day. But once you see this visualization, you kind of start grasping the atomic level depositions of, like, what's happening in the database, right? Like, it's atomic level, it's happening so quick and so fast that we don't really break it down to this level. And once you start breaking it down to this level, you start realizing how fast this data have to move, and how this data comes together in order to be something that, the way we see it today, the way we use it today, right? And anybody who's lived long enough to realize that internet was never this fast before. It used to be really, really slow, but it's getting faster and faster. The way we have internet today, the versus the way we had internet before, it's two different story. And we actually had internet built off of sort of the way we do information exchange within our brain. So this is a good transition into pick up and drop off inside of our brain. So I'll quickly run through it. But when we talk about data acquisition and MLOps, if you think about the five sensors in our body, which is the tactile, the touch senses, and your auditory cortex, and your motor cortex, and your visual cortex, and then you have your smell senses and your taste buds, right? All these senses are feeding into one single location where the data is being trained actually. And once these data are trained, they're deployed through a feedback loop mechanism, which we call the human body that we have, right? Where you are able to use your body language, your communication language, your ability to make eye contact with other people and pay attention to things. These are what's happening inside of our body through a data acquisition process. And once the brain picks it up, it does a model training instantaneously, which a system like machine learning by IBM or AI by OpenAI would love to mimic, right? But it's just not possible today. And even if it's possible, it probably doesn't need to be that complicated, because our brain is that complicated, with 86 billion some neurons that resides within your ears. So 86 billion neurons, trillions of synapses and dendrites, and that is a complex system that is very hard to mimic. But if you think about what AI machine learning is able to do, is kind of mimic just that pick up and drop off of all the information that is being fed, and it's being modeled and trained and being deployed for usage as it needed, right? And rest of it kind of goes into storage, right? If it's not being used, it just gets stored on the backside of the brain somewhere, subconscious mind, system 2 and system 1 and system 2 somewhere. So we talked about some of the complexities, and we're not going to take too much time here, but we wanted to get the introduction of MLOps going, and we wanted to bring the introduction of how MLOps is so similar to how our brain works, and how our brain works off of a feedback loop. So if you were to look in any system in around the world, or any planets around the universe, they're all based on feedback loop. And what we're trying to do is actually mimic the natural courses and natural ways of doing things through the data acquisition, and have that data being processed and trained for the purposes of AI generation. Um, and of course, if you look to the value of what's happening with AI machine learning, one thing that you will come to realize is that these AIs are just that powerful, because they're augmentating, excuse me, let me use the word augmentating the intelligence that we have within ourselves. So it's not necessarily mimicking to replace, it's more about mimicking to augment the intelligence that we have. So if we have to see things, how can we see better? If we have to hear things, how can we hear things better, right? It's changing. So if you're talking about AI machine learning for the purposes of language translation, is that augmenting us to learn the language, or augmenting us to hear the language in a different, the native language that we are accustomed to? So you have lots of ways to augment, and these capabilities, as you see it for workforce, you have multiple ways to look at it, right? Um, if you are thinking about, how do I develop this capability for my organization through MLOps? What do I need? You really need to understand that there is a need for upskilling your workforce, because they're the subject matter expert, they're the domain knowledge holder that needs to be upskilled for the purposes of AI machine learning. And as they come together with AI machine learning knowledge and their domain knowledge, what they will see is these lot of these requirements and use cases that augments the workforce and augments the workforce's domain knowledge, right? This domain knowledge comes together in order to benefit from these artificial intelligence and machine learning. So I'm going to stop here and kind of get started for the next weeks of conversation on MLOps, because we will have this continuous discussion about MLOps. It's not necessarily going to next week. It's going to be a few weeks down the road, because we try to keep some of these conversations as least technical as possible. But as we do understand MLOps more and more, what the difference will be that, if you're engaging with SMART community, you will see that the value that we bring to the table is not necessarily very technical or product based. It's more about how do you shape the workforce, and how do you create a change management process for your enterprise that is effective and that is fruitful and is scalable and sustainable, right? So SMART community, we stand for specialist, methods, M for methods, A for advocates, and R and T is for research and training. So when we are advocating for MLOps, what that means is that we want to have all the participants of businesses that used to stay away from tech side of things, for them to start investing their time and knowledge into this new technology, the new AI, the new transformation that we will experience in going forward in time. So we really want, evangelos, subject matter expertise come together with IO psychologist subject matter expertise, right? The subject matter expertise from, say, somebody who knows, a lot about data, a lot about machine learning, a lot about, the AI use cases. How do we bring all these different knowledge sets together, so that way when we go through this MLOps lifecycle, it's not only bringing in return on investment, but it's also scalable and sustainable, because people that uses it has a lot of interest in adopting it, and a lot of interest in using it for feedback loop purposes to grow it over time. So that's all I had for today's webinar. But before I go, Evangelos, any thoughts and comments on what we have discussed today, and what are you looking forward to in the next conversation? Maybe we'll pick that up as well.
There are plenty of things actually, and I was I think one thought that just emerged is in particular regarding the theme of engineering, which was in the Venn diagram you uploaded. I think it was the first slide. Yeah, and I'm curious to learn more about the concept of engineering, especially because we tend to use the singular like it is. Whereas in machine learning, or let's say in the construction of complex algorithms nowadays, we see that we need the cooperation of different groups and different people with different expertise until the development of the singular tool, for example. And I'm curious to learn how this obfuscates or doesn't really produce any confusion in adopting this kind of technologies in the workplace afterwards. If like this inevitable cooperation of different groups, different people, that kind of hinders comprehensibility in the long term. if that affects the adoption itself.
Yeah, it absolutely does, because that's the lessons we've learned for the last 20 years, is that when we talked about, like, you have underperforming AI deployment, or AIs that do not deploy, is because of what you just mentioned, is that the stakeholders are not involved, and people's understanding, the limited understanding of these AI machine learning, because they're so siloed and so segregated from each other. If we don't have a single baseline where everybody understands AI from a single baseline, it causes a havoc in a deployed AI environment. So let's say, for example, ChatGPT comes around. It's very useful to so many people, but then again, a lot of other people have other feelings towards it, and that makes it ChatGPT very hard to sustain. OpenAI's to continue with their services is very difficult for OpenAI to do, right? So the baseline is that you really have to understand where the data is coming from and how these data sets are, relevant to what's being accomplished. So it's not necessarily understanding mile 1 to mile 30. It's more about understanding, if there's a mile 1, what happens in mile 2, 3, and 4, 5, right? But of course, it eventually turns into mile 30 and mile 100, right? So as we discuss more about MLOps in coming weeks and months, we will see that more people that brings in their domain knowledge expertise, the picture, the ecosystem starts shifting, right? And it's the people that will use the technology. It's not the technology that will technology. It's the people that will use technology. But before we get to the point where technology is using technology, as in AI is making other AIs, we really need to get the peoples to buy in, so that way we can get to a point where AI does what it does without really disrupting our lives, right? AI sort of becomes that behind the scene system that we live with every day. Like I say, for example, a fridge in your house, right? It's quiet and cool, running all day long, keeping your food cold. We don't bother with our fridge every day, but with AI, it's not the same. But we want AI to get to that point where AI just works behind the scene, and we as humans, we do what we have to do, which is non-repeatable, non-redundant, and non-dangerous task, right? So I think there's a whole lot to unpack here, but this is a sample of what MLOps is. It is technical, but on the other side, it's not that technical, and I like that about MLOps, because it brings in lots of these stakeholders and business process owner and data process owners to the table, and have them discuss MLOps from a different perspective. So this is sort of like another tool, but a baselining environment where you can have people around the table and walk through the technologies for developing AI machine learning. All right. So thank you, Evangelos, and thank you, Michelle, for joining. Really appreciate the effort to be here today on a Monday morning. But every Monday morning, we'll try to be here and share some knowledge that we learn through our Zoom call on a weekly basis. And looking forward to the next one. Thank you all. Take care.